Okay, so we'll move further. Hmm, hmm. X to the 10. Yes, yes, yes. Yes, some answer. Okay, answer of coefficient of x to the 10 is equal to 856, right? 856.96. Okay, so that's one type of problem. We'll move further. The next type of problem. Okay, this is the question. Find the coefficient of x to the 7 in the expansion of ax squared plus 1 divided by bx raised to the power 11. Okay, the standard procedure will follow. Here a, b, etc. values are not given, so we get the answer also in the same format. So what is expected? We are supposed to get the answer in the same format like what we have here. Okay, right. So let's start the solution. Let's write tr plus 1. If I want to find any tr plus 1, this is the standard expansion 11cr. We have the first term, which is ax squared. This is being raised to the power 11 minus r. The second term, that is 1 divided by bx. This is raised to the power uh, r, right? Okay. So this means, try to simplify, 11cr. What is the a to the power? A to the power 11 minus r. There is b in the denominator, which is raised to the power r, into, let's try to write the x power. So x to the power, there is a square, right? So x to the power x square. So this is 22 minus 2r. So there is a r which is in the denominator, comes to the numerator as minus. So this means we can try to write this as 11cr a to the 11 minus r divided by b to the r into x to the power 22 minus 3r. Okay, so this is the r plus 1th term, right? This implies if you want to have x to the power 7, I should be able to equate these to x to the power 22 minus 3r. So that implies 7 should be equal to 22 minus 3r. Right. So 3r is equal to 22 minus 7, which is 15. So r is equal to 15 by 3. So r should be equal to 5. Okay. So that means r is equal to 5, right? So let us try to write the coefficient. This implies the required coefficient of x to the 7 is nothing but 11c5. into a to the power 11 minus 5, so 6 divided by b to the power r, so b to the 5 is the required answer. Then let us try to solve another question of very similar type. So find the coefficient of x to the power minus 7 in the expansion of ax minus 1 by bx square raised to the power 11. Okay, so the coefficient of x to the 7, this is equal to 11 c6 into a to the 5 divided by b to the power 6. So we have answer like this. That's correct. Let's move further. This is the next question. Find the term independent of x in the expansion of 3 by 2 x squared minus 1 divided by 3x raised to the power 9. So here we need to find the term independent of x, which means when I equate, when I find the tr plus 1, I have to have the x to the power 0, because x to the power 0, x to the 0 indicates 1, no x. Okay, so first let's try to write the tr plus 1. So tr plus 1 is, in this case, this is 9cr into the first term, that is 3 by 2 into x to the power 2 raised to the power 9 minus r into minus 1 divided by 3x raised to the power r. So this is equal to minus 1 to the power r into 9cr. Let's write the constant first, that is 3 by 2 raised to the power 9 minus r into, there is a 1 by 3, this is raised to the power r, into the x term. The first x square gives you 9, 2 into 9 is 18. So this gives you 18 minus 2r, and there is one more r coming from here, that is 3r. 18 minus 3r, right? So this is the r plus 1th term. Now you see, I should not have any x. So this term should be 1, right? So that something comes constant into 1, only constant. That term has no x, means this term should be equal to 1, right? So no x term implies the x to the power 18 minus 3r should be equal to 1. 1 can be written as x to the power 0. So 18 minus 3r should be equal to 0. So 3r is equal to 18. So you will find that this means the value of r becomes equal to 6. Right. Therefore, what is the term which has no x, right? We can find out that by using this. Implies you put minus 1 to the power r, 6, r is equal to 6, into 9c6 into, this is 3 by 2 raised to the power 3 into there is 1 by 3. 1 by 3 to the power r. So this is 1 by 3 to the power 6 into x to the power 0. That is 1. All right. So the answer is 7 by 18.388. Next question. Find term independent of x in, this is 2 by 5 times x squared, 17 divided by x raised to the power 11. So in this case, we are not getting the integer value for r, right? When we solve, we don't get this. So here the answer is no term independent of x. For this given term. Let's move further. The next topic is the p plus 1 term from the end, right? So far we were calculating from the beginning, right? Now, whenever I want to find the p plus 1th term from the end, right? So I'm actually talking about of the expansion of x plus a to the power n, right? So this nth p plus 1th term, so t p plus 1, but this is from end, so I write a t dash, okay, indicating that this is from n. N C P. See the difference? Now a becomes first, a to the power n minus p into x to the power p. Only this is the difference. Okay, quickly let's solve some fundamental problems now. So find fourth term from end in the expansion of this one, x cube by 2 minus 2 by x square, 2 by x square raised to the power 7. So notation t dash. So 4 is equal to 3 plus 1 is equal to is equal to, so this is 4, sorry 7, this is 7c, the p value that is 3, 7 3. So a is equal to minus 2 by x square to the power n minus p. So 7 minus 3 is equal to 4 into the first term, that is x cube by 2, x cube by 2 to the power p, that is equal to 3. So this gives you an answer equal to 70. Okay, the next question is find sixth term from n in the expansion of 4 divided by 7x cubed minus 12x squared raised to the power 70. The answer is 3,359 into x to the right. Next question. Find the n plus 1th term. Find the n plus 1th term from the end. In the expansion of 2x minus 1 by x raised to the 3n. The answer is equal to 3n cn x to the minus n into 2 to the power n. Yes, this is the required answer. Okay, the next concept. Okay, this is to find free from the radical or the rational terms in expansion of a to the power 1 by p plus b to the power 1 by q whole raised to the power n, where a comma b belong to prime numbers. So this is the point, right? I want to find out the free from radical or free from the uh, rational terms, right? How to find that, we'll see. So first, let us try to represent that equation for tr plus 1. R plus 1, the term should be, this is ncr into a to the power 1 by p raised to the power, whole raised to the power n minus r into the second term, that is b raised to the power 1 by q to the power r. Or we can simplify this and write the ncr into, this is a to the power n minus r divided by p into, this is the power b to the power r by q. Right. We have to do some inspection and we have to put the values of 0 to n to r whenever the indices of a and b becomes integer. That's what is our intention, because I don't want to have rational or radical terms, right? So what we have to do, we have to put 0 less than r less than n, right? Such that integers of a and b, a and b are integers. That is the solution. So to find the free from radical or rational terms means expand this and find out those values of r such a way that the a and b will become integers. right? So we will note some points here. This is important. Point number one. If indices of A and B are positive integers, then the free from radical terms will be equal to the terms which are integers, right? That means number of non-integral terms is equal to total number of terms minus the number of integral terms. So the question can come, find the number of integral terms in the expansion. Find the terms containing only integers. Find the terms containing not integers, right? Etc. Everything can be calculated by using this one concept. Okay, so let me write that. So if indices of say A and B are positive integers, this implies then free from radical terms, free from radical terms will become equal to the, those terms which are integers. Okay, so this itself can be used to further calculate the, therefore, the number of the non-integral terms equals to the total terms. Total number of terms are very well known. So total terms minus the number of integral terms. Integral terms. That's all. That's the rule number one. Let's find. If let us say that the indices of A and B both are not positive integers. Okay. So in that case, free from radical terms becomes equal to rational terms minus integral, because both A and B are not positive integers. Okay. So let's write that point. If the indices of both A and B are not integers. Okay. This implies then I can write therefore the free from radical terms equal to the total number of the rational terms minus the integral terms. Okay. Then if at all I want to find the number of irrational terms, this has to be equal to the total terms minus the rational terms. So these are the equations we have to use to find out the required answer for the upcoming problems. Problem number one. Find the number of terms in the expansion of fourth root of 9 plus sixth root of 8 raised to the power 500, which are integers. So I have to find out the number of integers in the expansion of this particular expansion, right? So the point says that we have to have the numbers which are prime. Then only this rule can be applied, because you see that a comma b are prime. So whatever you raise, right, that should be a prime number. So as of now, I can see that the given data is not prime, but definitely we can convert this into the prime. So let us try to write this. So the expansion is 9 to the power 1 by 4 plus 8 to the power 1 by 6 to the power 500. Okay, so this can be written as, I have to bring a prime over there, so I'll write 3 square. So 3 square into 1 by 4 plus 8 can be written as 2 to the 3. So now that is a prime. 1 by 6 whole raised to the power 500. So this is equal to 3 raised to the power 1 by 2 plus 2 raised to the power 1 by 2 whole to the power 500. So we got a plus b, something like that. Okay, a and b are prime. So write the tr plus 1th term. So this is 500 cr into 3 to the power 1 by 2 into 500 minus r, and 2 to the power half to the power r. Okay, so this is nothing but, we can expand this as, this is equal to 500 cr 3 to the power 500 minus r whole divided by 2 into 2 to the power r by 2. So I can further simplify 500 cr 3 to the power 500 by 2 is 250 minus r by 2 and 2 to the power r by 2. So this is the t r plus 1. So every term is like this. Anyway, 500 cr is going to give you integers always. Now, out of the whole terms, n number of terms, right? 501 terms we have here, right? How many numbers are integers? That depends upon this 3 to the power 250 minus r by 2, correct? So out of which half of them, right, from 0 to 250, right, I can definitely, if you calculate half of them, remaining will remain same. That's what is the point. So in this case, I have to put the values like 0 less than r less than 500 to check, right? So 0 to 500 you can put and you can check. One point is that whenever I put a multiples of 2 to this number, both are going to be, right, integers, right? Like put r is equal to 2. So that means 2 by 2, which is 1. 250 minus 1 is 249. So you see 3 to the power 250, 249 is a integer. Similarly, 2 to the power 2 by 2 is 1. That's a 2. That's also integer. So the point to understand. So till here we can do in every problem. The analysis part is left to us, right? So I'll just write one point for r is equal to, starting from 0 2 4 6 etc up to 500, right? Every even number, right? For every even number, comma 3 to the power 250 minus r by 2, and uh, this is 2 to the power r by 2. The indices are positive, right? 2 to the power this and this, right? Or I can write, I just talk about, I'll only talk about the indices. Okay, so not 3 to the power, because the note which we studied earlier, right, says that only it talks about only indices, not about the whole number. So for this range, the indices, what are the indices? First index is 250 minus r by 2, and the second index is r by 2, right? Are positive. Okay, so when they are positive, right, what are the total, right, number of integers you are going to have out of 501 terms, right? Take out the odd numbers. Odd numbers are 249, right? So starting from 1 till 499, you have 500 terms, right? So so this implies the total integers, total number, you see the equation, total terms 501 minus the number of integral terms, right, which are you subtract the non-integral terms. Non-integral terms means there are how much? 250 terms, which corresponds to, right, like r is equal to 1, 1 by 2, r is equal to 3, 3 by 2, r is equal to 5, etc. All those terms are subtracted. So totally you have 251, which is the right answer. Okay. The next question will be a homework question. So the question is to find the sum of the rational terms. Only the sum of the rational terms we want. Okay, so this is 3 raised to the power 1 by 5 plus 2 raised to the power 1 by 3 whole raised to the power 50.